Hi guys, welcome to science class from my kitchen again. Today we're going to start a short unit on plate tectonics. Now I know we talked about continental drift and Alfred Wegener a little while back, but Alfred Wegener died in 1930 on an expedition to Greenland, and he never really knew why the continents were moving. He knew that they were moving, but he didn't know how. The theory of plate tectonics explains how the continents move. Now remember, Earth's crust is made up of a series of tectonic plates. One of the ways that these plates get pushed around is through seafloor spreading. So we're just going to look today at these three things: seafloor spreading, the mid-ocean ridges, and the ocean trenches. Seafloor spreading happens when convection currents in the Earth's mantle force hot magma up through the crust of the Earth. This causes mountains to form under the ocean, and the seafloor is spread away from these mountains. The mountains are called mid-ocean ridges. Now obviously this process takes a lot of time. So you might be saying to yourself, Mr. Kane, how did scientists know that the seafloor is spreading? Well, I'm going to tell you. Harry Hess was a naval captain and geologist. He proposed the theory of seafloor spreading in 1960. Scientists use sonar to map the ocean floor. Here's a map of the mid-ocean ridges around the world. Much of the ocean floor is made up of basalt, which has some magnetic properties. When scientists decided to map the magnetism of the ocean floor, they discovered another piece of evidence to support the theory that the seafloor was spreading. Just look at this amazing graphic to see. As the rocks moved further away from the mid-ocean ridges, they no longer pointed to true magnetic north. Scientists also used radiometric dating to date the rocks on the ocean floor. They noticed that the newer rocks were closer to the mid-ocean ridges, and the older rocks were further away. Now I know what you're thinking. Mr. Kane, if the seafloor is spreading, then why isn't the Earth getting bigger? Well, that's because the Earth recycles the old oceanic crust. As the oceanic crust gets pushed away from the mid-ocean ridges, it collides with other tectonic plates and gets pushed back down into the mantle. When this happens, an ocean trench is formed. Ocean trenches make the deepest parts of our oceans. The deepest of these is the Mariana Trench in the Pacific. There's a CK12 assignment on Schoology and a couple National Geographic articles that'll go into a little more detail about these topics. And then there's a quiz for you to take on Schoology. This is due by 10 p.m. on Thursday. So I hope you guys are doing well. See you later.